Good day everyone, my name is B.Tonga, BSECE 3A. In this video, we're going to construct, simulate, and demonstrate a car's rear signal lights. First things first, here are the materials that we're going to utilize in the demonstration. First, these are 5 push-button switches, then red and yellow LEDs. It depends on how much you want to use, but it should be at least 2 yellow and 3 red. Of course, our Arduino Uno R3 board, our connecting wires, and lastly, our breadboard. I didn't include this, but it should be included also the USB CH340 USB controller. Now that we know the materials needed, let's delve in and understand the task that we are going to tackle today. Let's go to this PDF. As this PDF suggests, each of the 5 push-button switches have different functions. Let's start with the switch 1. It is the left signal light or the left turn. It is a blinking yellow. Press once to start and press again to stop. Switch 2 is a right signal light. It is also a blinking yellow. Press once to start and press again to stop. Switch 3 is running light. It is a steady red. Press once to start and press again to stop. Turn on or turn off. You might be confused why it's called running lights but steady red. It is called running lights because it is the lights that turn on at the back of the car while it is running on the road. Assuming the setting is a nighttime. I hope you understand that. Switch 4, hazard lights, the double flash mode. It will blink the left and right signal lights. Press once to start blinking and press again to stop. Finally, the switch 5 is the brake lights. It is on red, which means it is turned on if it is pressed, and turned off. It is turned off if it is unpressed. Meaning when you click the push button, it goes on. If you let go of the push button, it goes off. Now, to simulate and demonstrate the desired outputs of this task, I have created this schematic diagram that will be translated into our breadboard setup later on. As you can see, by the way, the switches that we are going to utilize are 2-pin push-button switches. In the software program that I have created this schematic, I can find a 2-pin push-button switch. So I've utilized this 4-pin and connected the 2 pins on the left and 2 pins on the right to make it a 2-pin. But you can also just use the 1 pin on the left and on the right and leave the 2 pins hanging, depending on you. If this looks complicated to you, I have created a simplified version of the previous schematic diagram. Here it is. Let me zoom in. There we go. Input pins 3, 4, 5, 6, and 7 of the Arduino board will be connected to switches 1, 2, 3, 4, and 5 respectively. Of course, also the 5-volt input voltage and the 10K and then 10 kilo ohm resistors, pull-up resistors connected to the switch and then to the ground. Then, here are the output pins. Output pin 13, 12, 11, and 10, and 9 are connected to our LEDs. Each of our LED, except for these ones in parallel, of course, it's an exception, have a 330 ohm resistor. And of course, the resistors are connected to their anode and their cathode are connected directly to the ground. Okay. Now that we are done with that, I'm gonna show you the program or codes that I've created to simulate the desired outputs of this task. I'm not gonna take up your time to elaborately discuss each code. I'm just gonna show it briefly to you. Anyway, you can just download my codes on the link in the description box below, together with the schematic diagrams. Now, this is the codes that I've constructed. in order to simulate the desired outputs for this task. This is the first declaration that I made. Of course, this is the void setup. And we have the void loop. This is the code for the first switch. Sorry. Now here's the code for the first switch. Let's move on. Here's the code for the second switch. Here it is. Okay. It is for the third switch. This is one. Third switch. It is shorter. Then this one is for the fourth switch, the hazard light. And of course, our last switch, our brake lights, is the code for the fifth switch. Again, you can just download it later on the description box below, or while you're watching this video. Let's now verify it. It may take some time verifying and compiling the sketch. Let us wait for it. And we are done. Now, before I upload this code to my Arduino Uno R3 board, let us first go to my workstation and construct our breadboard setup. By the way, if you want to learn how to install the USB CH340G driver, as well as this Arduino IDE, this program where I've constructed my codes, there is a tutorial on my channel together with the download links for these programs. Now, let's go to my workstation and see you there. And welcome to my workstation. Here we are going to construct our breadboard setup. Basically, we are going to translate this simplified schematic diagram and put it in here with the components that you can see right here. And of course, our Arduino Uno R3 board. Now, the first thing that I am going to do is put a jumper. This is a connecting wire that can be found inside a UTP cable. I'm going to put a jumper here to the, if you can see that, the negative. I'm going to connect these two. You may ask why, because in this schematic diagram, as you can see, the what do you call this? The resistors that are connected to the ground and the cathode of each LED are connected to the ground. They are basically in one connection. They are connected to each other. So I'm gonna put a jumper here to make sure that the negatives here and the negatives here are connected. Now, we're going to start this off in the output pins, basically the LEDs. As you can see, all of the resistors are connected to the anode of the LED, and the cathodes, as I said earlier, are connected to the ground. Now, this is an LED. The short one is the cathode, and the long one is the anode. You can put it however you like in the breadboard, just remember its orientation. And also remember that each column of holes here are connected, and right here each row is connected. From here to here, that's connected. From here to here, that's connected. While here, each column are connected. Then there is the division in here. Then each column are connected. Okay? Now, we are going to start with our LEDs. And we are done. As you can see, I put the resistors in the anodes. These two are in parallel as suggested in this schematic diagram. I put it in different places because we are going to simulate the rear signal lights of the car. So I've decided that this is the best design in the breadboard that I could give. Also, this is the LED 1 and LED 2, the left and right signal light. Now that we've done with the LED, you can see the cathodes in the ground. We're going to go to the switches. As you can see, the switches have a pull-up resistor, a 10K pull-up resistor that's connected to the ground. That's going to go right here. And then their second pin, this is a 2-pin switch, are connected to the to the input voltage, the 5 volts. Now, we're going to put the 5 volt input voltage here as in the plus sign, and the ground in the minus sign as obviously. Now, we are going to start our switches right now. Now we are done with the switches. As you can see, you may be wondering why I have put these connecting wires here. Well, if you look at the terminals of my 10K resistors, they are a little bit on the thin side. So I put these connecting wires here to make it a snug fit, so that it is not a loose connection, as well as these 330 ohm resistors. Instead of putting them in the adjacent holes, I put them in the anodes, directly to the anodes of the LEDs, to make it a snug fit as well. Now, as you can see, we are done with the switches. Now we are going to move on to connecting the Arduino Uno R3 board to the breadboard using these connecting wires right here. If you buy an Arduino kit, these connecting wires are also there. But if you buy an Arduino Uno R3 board alone, there is no connecting wire, so you have to buy it separately. So I suggest you buy a kit. Now, this is the CH340G USB controller. And these connecting wires here, these longer connecting wires, we're going to use this as the 5 volt for the 5 volt input and for the ground. Now, as the schematic suggests, the input pin start at input pin number 3, if you can see that, up to input pin number 7. Input pin number 7 for the switches. Now, for the LEDs, the first LED to the last LED, the output pin, it starts at 13, if you can see that, then ends at 9. Basically, the 8, 2, and 1 sin 0, 8, 2, and 1, 0, and are the only holes that we are not going to use here. Now, this is the 5 volt input pin. If you can see that, yep. And next to it are the two grounds. You can put the ground connector wherever you want. That's what we're going to use to power this demonstration. Now we're going to start connecting this board. And we are done connecting the breadboard setup to the Arduino board. I've also connected the CH340 USB to the Arduino board. Now we are going to connect this Arduino to our laptop, then upload the code. Now we are going to connect the Arduino board to the laptop. As you notice, I have turned off the flash of my camera or my lights. The reason for that is for you to see the lights or the demonstration very clearly. Now I'm gonna move the camera here. I'm gonna connect the Arduino board. Let's lift that up. Yes. I'm gonna connect the Arduino board in my laptop. I'm gonna start uploading. I don't know if you can see the laptop. Nope, it's too bright. Just focus on the Arduino and the lights. And then you will know when the code is done uploading. You will see it blinking, right? There it is. That means it's done uploading. Now, we're going to start the demonstration of a car's rear signal lights. Starting with switch 1, the left turn. As you can see. Switch 2, the right turn. There we have it. Switch 3, the running lights. This is the light that turns on when the car is running on the road. I don't know if you can see that, but it is lighting up. It is quite dim, but it is lighting up. Turn that off. Now we have the hazard lights. Sort of a warning light if you are parked in BC road. And last but not the least, the brake lights. Here it is. Okay. It might seem dim here, the LED here, but it is lighting up, I promise. And there you have it. Now, we are not done yet. To finish this task, I will embed this breadboard setup into a toy car to make it a little bit more realistic demonstration or simulation of a car's rear signal lights. And I am going to do that, and I am going to show you the final output for this task in 3, 2, 1. And here we are. This is the final output for this task. The breadboard setup earlier, if you recall, are now permanently embedded inside this car. As you can see, these are switches 1, 2, 3, 4, and 5. And the LEDs, yellow and red LEDs, if you can see that. Of course, we have the Arduino Uno R3 board in here, but it is not permanently embedded because we can still use it for future projects. The other components are in here. I'm sorry, it is not a pretty setup to look at, but it functions, so it's fine. Well, for me it's fine. Now, you may be wondering why there are sticks here that is raising the hood of this car. The reason for that is I have made a big miscalculation about what size of a car should buy, a toy car should buy. I bought this because I took advantage of the positioning of the lights here, but it is not wide enough or big enough to fit the components and the board and closed it. I tried closed it forcefully, but it damaged the board a little and the components, and it malfunctioned badly. So you can just think of it as a car that is being fixed in a mechanical shop. Now, let's power this on and see the desired outputs. I'm gonna use my my laptop for power purposes, but you can also use a 9-volt battery or your phone charger here. I'm gonna plug it in. There we are. We have power now. Now, the first switch is the left turn signal light, as you can see here. Second switch, the right turn signal light. Third switch, the running lights. Fourth switch, the hazard lights. And fifth switch is the brake lights. And there we have it. As you can see, it functions really well because I did not close it up forcefully. Now you can learn from my mistakes. My advice is buy a bigger car, maybe wider and taller, and don't use too much stick glue. That's my mistake here. Now, I hope you find this video helpful for those who are watching this video. And I hope to see you again for a next Arduino project. Thank you and have a good day.